It is not permissible to run branch circuit conductors from two distinct service panels within the same conduit. The National Electrical Code, or NEC, sets forth specific requirements addressing this scenario. Firstly, Section 300.3 Bone explicitly states that conductors originating from different electrical systems shall not occupy the same enclosure, raceway, or cable. Secondly, Section 300.3b2 further elaborates that conductors of differing systems are prohibited from being installed in the same raceway, nor can they be installed in separate raceways that are positioned either side by side or stacked vertically. The underlying reasoning for these regulations is rooted in safety and the prevention of potential hazards. Utilizing a shared conduit for branch circuits sourced from different service panels contravenes these NEC stipulations for several key reasons. 1. It introduces a mixture of conductors from two disparate electrical systems, specifically a 120/208 volt system and a 277/480 volt system. 2. These panels have the potential to supply power to entirely different electrical equipment or loads. 3. The combination of different systems could give rise to various safety hazards. As an acceptable alternative, should there be a need to route branch circuits from both service panels to the same physical location, a permissible method involves installing separate conduits for each respective service. This practice ensures that the conductors from each distinct electrical system remain isolated from one another, thereby adhering to the requirements outlined in the NEC. Now let's delve deeper into the intricacies of these NEC sections and explore the potential hazards that can arise from non-compliance. Section 300.3 Bowen is quite clear in its prohibition of mixing conductors from different systems within the same enclosure, raceway, or cable. The term different systems refers to electrical systems operating at different voltage levels or having different grounding configurations. In this case, a 120/208 volt system and a 277/480 volt system are considered different systems due to their differing voltage levels. The primary concern here is the potential for insulation failure and subsequent short circuits or ground faults. When conductors from different systems are bundled together in the same conduit, the insulation on these conductors can be subjected to increased stress due to the combined heat generated by the conductors. This is especially true if the conductors are carrying significant current. Over time, this increased stress can lead to the degradation of the insulation, making it more susceptible to failure. If the insulation on a conductor fails, it can create a direct electrical connection between the conductor and the conduit, or between conductors of different systems. This can result in a short circuit, which is a sudden and uncontrolled flow of current through a low resistance path. Short circuits can generate a large amount of heat, potentially causing fires or explosions. They can also damage electrical equipment and pose a serious shock hazard to personnel. A ground fault is a type of short circuit where the electrical current flows from a conductor to ground. This can occur if the insulation on a conductor fails and comes into contact with a grounded surface, such as the conduit itself. Ground faults can also be dangerous, as they can cause electrical shocks or fires. Section 300.3b2 further reinforces the prohibition of mixing conductors from different systems by stating that they cannot be installed in the same raceway or in different raceways that are installed side by side or stacked vertically. This requirement is intended to prevent the inductive coupling of electrical noise between the different systems. Inductive coupling occurs when the magnetic field produced by one conductor induces a voltage in a nearby conductor. This induced voltage can cause interference with the operation of sensitive electronic equipment. For example, if a 277/480 volts lighting circuit is run in the same conduit as a 120 volts control circuit, the inductive coupling between the two circuits can cause the control circuit to malfunction. This could result in unexpected equipment shutdowns or other operational problems. The requirement to separate raceways that are installed side by side or stacked vertically is intended to minimize the inductive coupling between the different systems. By maintaining a physical separation between the raceways, the magnetic field produced by one circuit is less likely to induce a voltage in the other circuit. Now, let's consider the acceptable alternative of installing separate conduits for each service. This approach ensures that the conductors from the different systems remain isolated from one another, thereby minimizing the risk of insulation failure, short circuits, ground faults, and inductive coupling. When installing separate conduits, it is important to maintain a reasonable separation between them. This will further reduce the potential for inductive coupling and ensure that the different systems operate independently of one another. In addition to the NEC requirements, there may be local codes or regulations that further restrict the mixing of conductors from different systems. It is important to check with the local electrical inspector to ensure that your installation complies with all applicable codes and regulations. In summary, running branch circuit conductors from two different service panels in the same conduit is a violation of the NEC. This practice can create a number of safety hazards, including insulation failure, short circuits, ground faults, and inductive coupling. To ensure the safety and reliability of your electrical system, it is important to install separate conduits for each service. Furthermore, it is crucial to emphasize the importance of proper grounding in electrical systems. Grounding provides a low impedance path for fault currents to return to the source, which helps to quickly trip circuit breakers or fuses and energize the circuit in the event of a fault. This reduces the risk of electrical shock and fire. The NEC contains detailed requirements for grounding electrical systems, and it is essential to follow these requirements carefully to ensure a safe and effective installation. Another important consideration is the proper selection and installation of overcurrent protection devices, such as circuit breakers and fuses. These devices are designed to protect electrical circuits from overloads and short circuits. When selecting overcurrent protection devices, it is important to choose devices that are properly rated for the circuit they are protecting. The NEC contains tables and guidelines for selecting the appropriate overcurrent protection devices for different types of circuits. It is also important to ensure that overcurrent protection devices are properly installed and maintained. This includes verifying that the devices are properly connected to the circuit and that they are functioning correctly. Regular inspection and testing of overcurrent protection devices can help to identify potential problems before they lead to failure. In addition to the technical aspects of electrical installations, it is also important to consider the safety of personnel who may be working on or near electrical equipment. Electrical work can be dangerous, and it is essential to take appropriate precautions to prevent electrical shocks and other injuries. This includes wearing appropriate personal protective equipment, such as gloves, eye protection, and arc-rated clothing. It also includes following safe work practices, such as de-energizing circuits before working on them and using lockout/tagout procedures to prevent accidental energization. Proper training and education are also essential for electrical workers. Workers should be trained on the hazards of electricity and the safe work practices that should be followed to prevent injuries. They should also be familiar with the NEC and other applicable codes and regulations. Finally, it is important to remember that electrical safety is a shared responsibility. Everyone who works with or around electricity should be aware of the hazards and take appropriate precautions to prevent accidents. By working together, we can create a safer environment for everyone. Let's expand on the potential consequences of neglecting these safety measures and code requirements. Imagine a scenario where conductors from the 120/208 volt system and the 277/480 volt system are indeed run within the same conduit, disregarding the NEC stipulations. Over time, the insulation surrounding these conductors begins to deteriorate due to the combined effects of heat, vibration, and environmental factors. This degradation weakens the insulation's ability to contain the electrical current. Eventually, a point is reached where the insulation fails, creating a direct path between a conductor from the 277/480 volt system and a metal conduit. This results in a ground fault, where a large amount of current flows from the high-voltage conductor to ground through the conduit. If the grounding system is not properly installed or maintained, the fault current may not be sufficient to quickly trip the circuit breaker. This can cause the conduit to become energized, posing a significant shock hazard to anyone who comes into contact with it. Furthermore, the excessive heat generated by the fault current can ignite nearby combustible materials, leading to a fire. Even if the grounding system is functioning correctly and the circuit breaker trips, the arc flash that occurs during the fault can cause severe burns and other injuries to anyone in the vicinity. Now let's consider a different scenario where inductive coupling becomes a problem. Suppose that a 277/480 volts lighting circuit is run in close proximity to a 120 volts control circuit that is used to operate a critical piece of equipment. The magnetic field generated by the high voltage lighting circuit can induce a voltage in the low voltage control circuit. This induced voltage can interfere with the operation of the control circuit, causing it to malfunction. As a result, the equipment may shut down unexpectedly, leading to a disruption of operations and potential financial losses. In some cases, the malfunction of the control circuit could even create a dangerous situation. For example, if the control circuit is used to operate a safety system, its failure could leave personnel unprotected from hazards. These scenarios illustrate the importance of adhering to the NEC requirements for separating conductors from different systems. By installing separate conduits for each service, you can minimize the risk of insulation failure, short circuits, ground faults, inductive coupling, and other hazards. In addition to the safety benefits, following the NEC requirements can also help to ensure the reliability and longevity of your electrical system. When conductors are properly installed and protected, they are less likely to be damaged by heat, moisture, or physical stress. This can extend the lifespan of the conductors and reduce the need for costly repairs or replacements. Furthermore, a well-designed and properly installed electrical system can improve the efficiency of your operations and reduce energy costs. By minimizing voltage drop and losses, you can ensure that your equipment receives the power it needs to operate optimally. This can lead to increased productivity and reduced energy consumption. In conclusion, running branch circuit conductors from two different service panels in the same conduit is a practice that should be avoided due to the potential safety hazards and code violations it creates. Adhering to the NEC requirements for separating conductors from different systems is essential for ensuring the safety, reliability, and efficiency of your electrical system. By following these guidelines, you can protect yourself, your personnel, and your property from the dangers of electricity. Finally, always consult with a qualified electrical contractor for any electrical work to ensure that it is performed safely and in accordance with all applicable codes and regulations.